Good afternoon, everyone. Myself, I am Madhavi Devi, working as Assistant Professor in Institute of Aeronautical Engineering College, Hyderabad. Today's session, we will take the lesson on the evolution of different types of the operating system and what are the popular types of the OS currently using in this world. So these two topics are going to discuss in today's class. So the session outcomes. So we will discuss the evolution of operating systems which are going to use in different computing environments, and we will discuss the popular OSs are presently used in the current world. These are the outcomes you are going to get it from this session. So in last session, we have discussed what is operating system and what are the different components of the abstract view of the components of the computer system, and what is a computer system structure is built, and what are the different types of computer system operations. Under that, we have discussed about the IO system and storage system structures, and these are the different topics we have studied in the last session. So now in this today's session, we will discuss the types of the operating systems. So under that, the first is batch operating system. It is a very old operating system which is initially evolved. And the second is multiprogramming operating system and time sharing operating system, multiprocessing system, distributed operating system, network operating system, real-time operating system, embedded OS, embedded operating system. These are the different types of the operating systems we are going to discuss in the today's session. Come to the simple batch system. What do you mean by batch? Batch is in the sense of that a group of tasks or group of the people. Right? Here we are considering the group of tasks. So the tasks which are of the similar kind, that we are making the group together and we will give it to the operating system to do the processing. So that is actually in the older days, we don't have much processing power. We don't have much memory. So everything is very limited. So those days, so this is actually the simple batch systems. Operating system is actually they have used. There is no direct interaction between the user and the computer here. So user will come to the computer place and he will submit his job for the processing. That's why there is no direct interaction between user and the computer in batch systems. The user simply submits a job to a computer operator, and then computer operator look at the similar kind of the jobs and keep it in a one batch and submit to the input device. These jobs are batched together by type of languages and the requirement. So after that, a special program in the computer, which is nothing but a monitor, which will take care of the process of the jobs. The monitor is always sit in the main memory and available for the execution. If you observe the architecture of the batch operating system, here these are different users. Now suppose in this time also, if you observe an example, now if you want to print 100 pages or 1000 pages, what you will do? You simply go to some shop and you will submit your job. And if any person is having of the same similar kind of the job, so then actually that operator will pull together the jobs and keep it for the printer. Keep it that job to the printer for doing the printing. So here these are different users. They are submitting the job and here the computer operator will visit and collect the jobs, and then according to requirements, the similar jobs are grouped together and make it as a batches. That batches are submitted to the computer, and computer will do further processing and give the output back to the user. This is what batch operating system. So let us see what are the advantages and disadvantages with the batch operating systems. So it is very difficult to know the time required for any job to complete. So we ourselves don't know when actually job is going to complete. And another is multiple users can share the batch systems, and the ideal time for the batch system is very less, because here the similar kind of the jobs they are submitting and they are giving to the system. So there is no ideal time for a job. Batch system is very less. It is easy to manage large work repeatedly in batch system. These are the advantages with the batch operating system. And then come to the disadvantages. The computer operators has to be very efficient and very effective to have to batch together the similar kind of the jobs. And the batch systems are hard to debug. Suppose if the operator is doing the wrong, then actually there is a chance of one job is going to misplace in another batch pool. So then actually where is the error is going to occur? That debugging is very difficult in the batch systems. It is sometimes costly. The other jobs will have to wait for unknown time if any job fails. Suppose somewhere in between, actually if some job is failing, actually the other person has to wait till that has to recover. The examples of the batch operating system jobs are payroll systems and banking statements. These are the actually the kind of application we can give it as a batch, and we can allow to use under batch operating system. Now come to the second type of operating system, multiprogramming operating systems. So in this, the word itself has given multiprogramming, means that more than one are running multiple programs at the same time, same time in the sense of that parallelly. So different programs are running parallelly. So it requires multiplexing. You may have studied in your computer organization and architecture multiplexing concept. Multiplexing is nothing but sharing the CPU. Sharing. It's just simple. That meaning of the multiplexing is nothing but sharing. Here we are sharing the CPU resource. So in multiprogramming, more than one job, it will execute parallelly at the same time. Suppose if you take an example, here the Firefox or Mozilla Chrome or some browsers, and another application is Word, and another application is Java, and again parallelly it is another Firefox browser or Chrome browser, Word. It is actually that parallelly, if you observe, this is a timeline and parallelly keep on going. These all the jobs are executed parallelly. More than one job are executed parallelly at the same time. That means that sharing the CPU between different application for the processing. This we are calling as multiprogramming. So multiprogramming is nothing but running multiple programs at the same time. That is multiprogramming. So while doing the processor CPU transfer from one program to another program, that we will term as context switching. Switching between one program to or one process to another process. That is nothing but context switching. So now let us see how actually the architecture or the memory layout of this multiprogramming operating system in our operating system. Initially, operating system will be placed on top in low memory, and then job 1, Job 2, Job 3, Job 4. These are the different jobs or different tasks. In my lectures, I am going to use job, tasks, and job, task, processes. These three words, job, tasks, processes. These three terms we will use interchangeably with the same meaning. So don't get confused. All are having the same meaning. Okay. Job is nothing but a task. Task or process is a piece of program in execution. That is nothing but a process. All these terms are having this similar meaning. These three terms we will use it synonymically in our lectures. So here 4 jobs are parallelly running, executing at a same time. That's nothing but multiprogramming. Here multiple jobs will be sitting in memory. CPU is multiplexed between these jobs. Single user cannot keep the CPU and IO devices busy at all times. When it has to wait, for example, for input-output purpose, and this operating system has to switches to another job to make the CPU busy. Suppose you may come across, you may have observed in your program also. So sometimes your program, in your program, you are waiting for input has to come and then has to execute further program. That time, this operating system will be switched to another job to make the CPU very efficient. So this multiprogramming organizes jobs, code and data. So CPU always has one to execute. In other words, in meaning a subset of total jobs is in a system is kept in the memory, and one job is going to selected and run via a job schedule. Right? So here job scheduler will take place and pick the job from memory and send the job for the execution. So with the advantages of the multiprogramming operating systems are, it provides less response time, means that once actually user submitting a job to the processor, then actually within less time actually it will respond and start do the execution. It may help to run various tasks in a single application simultaneously, and it also helps to improve the turnaround time for the shortest time task. Here the turnaround time is in nothing but when user is trying to submit a job to finish the job. Suppose I have one task, when I am submitting for processing, then when it has completed, the difference between that time is nothing but the turnaround time. Further, it helps to improve. Multiprogramming helps to improve turnaround time for the shortest time tasks. It helps to optimize the total job throughput. Throughput means that the number of tasks are completed per unit time is nothing but throughput. Number of jobs or tasks completed per time unit is nothing but throughput. So it also helps in improving CPU utilization, because obviously if you are able to process, executed, completed the more number of jobs, means that you able to improve the CPU utilization and never gets idle. So with this actually what is achievement you have achieved? The resources are utilized smartly. Come to the next disadvantages. So here the CPU scheduling has to be required, because some software or some scheduling algorithm has to be present in CPU and do the scheduling. That must be required. Without that, then it will be the tug of war like kind of thing. It will be who is going to come and who is going to get the execution like kind of thing. So scheduling algorithm will be take care which job has to pick from the memory and send it to the CPU. The memory management is also needed. in the operating system because all types of tasks are stored in the main memory, and sometimes long time jobs because whatever scheduling algorithm you have chosen in your CPU, that based on that algorithm the number of jobs will be picked from memory. So in that process, long time jobs may have the chance to get long time, to get a option, to get a opportunity to execute inside the CPU. So let me go to the another type of operating system, time sharing system. It is also, and another word is multitasking systems. So sometimes some people will use different terminologies, time sharing system or multitasking systems, or both are same. Here the name itself has the meaning of time sharing. Means that here the CPU is meant for the execution, doing the jobs processing, right? So there while doing the execution, the time will be splitted and give it to each and every job. See, I have job 1, job 2, like this. I will give it a 10 minutes of the CPU time. Job 2 will get 10 minutes of the CPU time. Suppose if single job is required 15 minutes of the time of CPU to finish the execution. So first initial step, the CPU will allocate to the particular job 10 minutes, and next job 2, like that based on the scheduling algorithm, that jobs will be executed. Next, whenever turn comes, again the remaining 5 minutes are going to be executed. It based on the scheduling algorithm which will be picked. Here what is actually most important in time sharing system, operating system is, it is actually the time will be allocated to each and every job. So in another words, it is a logical extension of the multiprogramming concept only. So what is multiprogramming? Running more than one job at the same time. Here also in time sharing system also, running more than one job same time, but here the time is constrained each. So that actually what is actually impression we are going to give to the user or to the customer means that interactive computing. Means suppose if here in this sharing system, in this operating system, one job or one user can't able to take much time to execute with the CPU. So fixed time slots will be allocated. Once the time slot is over, then it has to go back and sit again back in the ready queue. So that's what actually here the time sharing systems will give more interactive computing nature. So here the basic features is response time should be less than 1 second. In later chapters we are going to study, when we are going to study in the process scheduling algorithms, there the different kind of the scheduling algorithms. That time we are going to discuss about of the time sharing systems is going to use round robin scheduling algorithm. So what actually the scheduling algorithm, round robin scheduling algorithms will achieve this scheduling. That we will discuss in the later classes. So here each user has at least one program executed in the memory. If several jobs are ready to run at the same time, then CPU scheduling algorithms will be decide what job has to pick from the memory and give it to CPU. This is all about a time sharing system. Now let us see. So what we are achieving with this time sharing system also, low response time. This is the main output we are going to achieve with this type of OS. So here this also follows multiprogramming, but it is a logical extent. Time slots will be, time slices will be derived. Now let us see the difference between of time sharing and multiprogramming system. So in time sharing system, what I explained earlier, it is logical extension of the multiprogramming. In this computer, resources are allocated to many users or processes or within respective time slots, this is most important, within their respective time slots only it will get the CPU for further execution. In multiprogramming operating system, it allows to execute multiple processes by monitoring their process state and switch in between the processes. So the another difference is time sharing OS has fixed time slice, but multiprogramming operating system doesn't have any fixed time slice. So here in this operating system, it depends on time to switch between different processes. But in this multiprogramming OS, system depends on the device to switch between the tasks such as I/O, interrupts, etc. Here the prime focus is on low user response. Here the prime focus is on how efficiently we will use the CPU and memory, utilize it properly. So the system model of this time sharing system is multiple programs and multiple users. And here the system model, if you observe the system model of multiprogramming system is multiple programs. So here also multiple programs and multiple users, but here multiple programs. It concentrate on. That's why time sharing system is, I am saying that interactive computing to the users. It will give more interactive. So in this process, 2 or more users can use the processor in their terminal, but in this process can be executed by a single processor. So I can say, if you take it up for time sharing systems, so here so next operating system is multiprocessor operating system. So here the word itself, multiprocessor operating system, more than one processor. Till now in before operating system, single processor operating system is resided in a single systems. Now come to the multiprocessor system, more than one processor, and also known as parallel operating system and also called as tightly coupled OS. So if anybody has used it, tightly coupled OS means that multiprocessor operating system. Here more than one processor is sitting. These systems have more than one process in close communication, that sharing the computer bus. This is more important. That's the reason actually we call it as tightly coupled system, tightly coupled operating system. So we may come across in the later sessions what is loosely coupled systems. It is vice versa. So if you do not share the computer bus or any resources, then it is going to be loosely coupled. But here more than one process is close communication, that sharing the computer bus, the clock, and sometimes memory and peripheral devices. So here the sharing will be happen. That's the reason we are call it as this multiprocessor systems or operating systems, or another word is tightly coupled operating system and another word is parallel operating system. It executes multiple jobs at the same time. And makes the processing faster. See, suppose some scientific applications must require more and more calculations, particularly the space applications, and where in scientific applications it requires more calculations to come to the inference or to take the output. So if you take in healthcare sector also, more number of application has to execute parallelly and take the decision output. So at those times actually multiprocessor operating system will be more efficient. It supports large physical address space and larger virtual address space. If one processor, so what is the main advantage with this multiprocessor systems means that if one processor fails in a system, then the job, it doesn't get sit in the idle stand. it will give it to other processor and make sure that the process is going, that job is going to finish up. So if one processor fails, then the processor should retrieve the interrupted process state so the execution of the process can continue. Suppose if in single processor system, if the processor is failed, what will be happen? The jobs, whatever it is submitted for execution, it is going to be wait. So here the main advantage is if one processor fails also, the other rest of the processor will take care from that state where the last state is stored and it will start doing the execution. So in that process, we require inter-process communication mechanism. Inter-process communication means one process can be communicate with the another process. Is provided and implemented in the hardware system. So the main advantages with the multiprocessor system is, with this everyone know that if you are keeping more people, suppose if you are playing and if you are adding more players in the game, obviously that team is going to win it, right? The same fashion you are able to achieve the enhanced performance. So execution of several tasks by different processors concurrently. So that what will be happen? The application is going to complete very quickly. Increases the system's throughput without speeding up the execution of a single task. Right? Obviously, throughput will be improved. Throughput of the system will be improved. Let me see the another type of operating system, distributed operating system. So here in this operating system, we are going to briefly discuss all the things. So various autonomous interconnected computers communicate with each other using shared communication network. In distributed operating system, different stations, different terminals are communicated through a network. Each other, different autonomous, this is one system, this is one kind of system, this is one kind of system, this is one kind of system. All these machines will be connected via a communication network that is either of the LAN, WAN or MAN. Right? So these systems can able to communicate. They can able to send the messages, they can able to receive the messages, they can do any type of communications. So independent system possess their own memory unit and CPU. Before in multiprocessor system, what actually there it share the sum of the resources. That's why multiprocessor system we call it as tightly coupled operating system. So come to the distributed operating system. What we are observing here, each and every machine is itself is having their own resources, own memory and own CPU. Those are just communicating via communication network to send the different kind of messages and all. So that's why distributed operating system we are call it as loosely coupled system. In gate point of view and in competitive examinations, the people will ask you the multiprocessor systems are tightly coupled systems or loosely coupled systems. So you have to put the correct option is tightly coupled operating system. Distributed operating system is loosely coupled operating system. Why means that it itself is having of each and every terminal, each and every workstation or each and every user, whoever is communicated or in that pool, they have their own memory, they have their own CPU. So examples for the distributed operating system, Locus, DISIC. So many still it is existing, but I have taken only 2. So now come to the network operating system, the another type of operating system. These systems, the network itself is having the meaning of you have to follow either client server architecture. These systems run on a server and provide the capability to manage the data, users, groups, security, applications and other networking functions. So network, when actually network operating system, this operating system will be reside in a server place, and the all users will be communicate to complete their jobs. The jobs are here: managing data, groups, security, application, and all other networking functions. So, and once actually the operating system is stored in server place, it allow shared access of files and printers, security, application, and other networking functions over a small private networks. The operating system will create an environment to share all these, to do this all functionality over the network. That we are going to call it as networking operating system. So the other computers are called client computers, and each computer that connected to a network. See, so if I am considering this is a server, this is a computer. So here also different computers, and these computers, other computers, are that connects to the network server and running the client software to perform some specific service. So these are popularly, obviously here sharing is also happened. The resources are shared. So we are going to call it as these, all the systems are tightly coupled systems. So now come to the advantages of the network operating system. So with this, what will be the client systems doesn't have their own operating system, but actually the server is having an operating system, and it will perform the their specific task with the network operating system, with the server. That terminology we will use it as client server technology. And these are highly stable centralized servers, and security concerns are very high, are handled through servers, and the new technologies and hardware upgradations are easily and integrated with the system. So here server access is possibly remotely from different location and types of the system. So now come to the disadvantages of network OS. Servers are very costly, and user has to depend on central location for most operation. If the server is failure, then all the tasks are going to be delayed. So here maintenance and updates are required regularly to make the system going to be efficient. And here for the examples of network OS: Microsoft Windows Server, Unix, Linux, Mac OS, Novel Network, and BSD, etc. So come to the next, real-time operating system. These type of OS serve real-time systems. Here the time interval is more important. Time is more important, and this real-time operating system we will use for the critical task operations. And the time interval required to process and respond to inputs are very small. The time interval is called response time. So in before topic also we have used response time. What is response time in the sense of the time interval is very less. So real-time systems, the missile systems, air traffic control systems, robots, and all these are real-time system. Here guarantees the maximum time for the critical operation and complete them on time. Particularly see air, if you take it off air flights, so flights has to give it a reach to the on time to the destination scheduled time, and if any service required, and that has to finish within a time. Even traffic signals, you can't able to bypass the time. It has to every 5 minutes or every 10 minutes, whatever it is set in that embedded device, It has to work so that actually the other trains are not going to collide or anything. It is going to be happen. That applications are nothing but real time. In those type of applications, we require real time operating system. So if the job able to finish within on time, that we call it as hard real time operating system. So the another type of operating system, soft real time system. And here in this soft real time systems, we no need to worry more about of the deadlines. So here like just uh, only guarantee a maximum of the time for the critical task will get priority over other tasks, but no guarantee of completing it in defined time. That we are going to call it as soft real time systems. So these are another kind of operating system, embedded operating system. So what you are going to see in a small Palm OS, Symbian, and automobiles, barcode scanners, cell phones, actually small devices, this embedded operating system will be inbuilt and it make functioning. Those kind of operating system we are call it as this embedded operating system. So now come to the next personal computer or desktop operating system. So here this operating system is having of responsible for several tasks, and these tasks are broadly categorized into process manager and memory management, device management, storage management. And here now come to the popular types of the OS. Desktop class Windows OS, Unix, Chrome OS, and server class Windows Server, Mac OS, Unix or Linux. So mobile class Android and iOS, Windows Phone. So these are the different types of the OSs we have observed. And come to the desktop class operating system, Windows, DOS, Unix, Linux, Macintosh platform, Mac OS, iPad, iPhone platform, iOS. You may have come across so many of these things actually. So MS DOS, it's a previous, before Windows actually we have only MS DOS, Microsoft Disk Operating System. This only we have single user, single task OS. So here it is a 16-bit only. Now we are using of 64-bit, 128-bit also we are using of that processor configurations. So these are the Microsoft Windows and Google Chrome OS. So come to the server operating system, and these are the actually Android, iOS. I just give it a glance. Actually, these are the different operating systems that are available. So Linux actually it is a open source cross platform operating system, and it is freely available. So that actually it is more. If you observe in the international level, actually the people won't spend for the softwares; they will take it up. The open source software for their system has to be functioning. So these are different advantages of the Linux operating system. So with this, what we learned in today's class, we have learned different types of the operating system: simple batch, multiprogramming, multiprocessor, and the real-time systems and embedded systems. So multiprocessor, these are all the different types of the system, and what are the different popular voices nowadays we are using. These are the operating system we have studied in this today's session. In tomorrow's session, we will see the next further concepts in operating system. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.